Let's take a look at rotations. Rotations have three important parts. The first is how many degrees and direction. So you can have 90, 180, or 270 degrees, and you can rotate clockwise or counterclockwise. Clockwise is when you are traveling to the right. Counterclockwise is when you are traveling to the left. Okay, rotating right is clockwise, rotating left is counterclockwise. Each quadrant is 90 degrees. So if you go from quadrant 1, which is this, to quadrant 2, which is this, you have moved 90 degrees. 2 quadrants is 90 degrees twice, which means that if you have gone from quadrant 1 to quadrant 3, you have rotated 180 degrees. 3 quadrants is 90 3 times. 9 times 3 is 27. So if you rotate from 1 quadrant to 3 quadrants away, that becomes 270. So if I am at my original quadrant, if I start here, if my shape is 90 degrees here, this would be counterclockwise because it went to the left. If I continued, this would be 180 degrees counterclockwise. And if I continued to here, this would be 270 degrees counterclockwise. Now let's say I want to go to the right. If I go to the right, that is too big. There we go. If I go to the right, if I go clockwise, this is 90 degrees clockwise. If I continue, this is 180 degrees clockwise. And if I continue one more time, this is 270 degrees clockwise. So you'll notice that 1 away is always 90. 2 away is always 180. But you have to be careful because 1 away clockwise is the same as 3 away counterclockwise. Take a look at this. 90 degrees counterclockwise is the same as 270 counterclockwise. 90 degrees counterclockwise is the same as 270 degrees clockwise. The difference is going to be where those points are. So you have to be careful. But 180 always matches. Now let's take a look at a one-dimensional rotation. First, I'm going to rotate this clockwise by 90 degrees. You'll notice over here it says the coordinate numbers are preserved. This coordinate is 3, 2. That means no matter what kind of rotation I do, no matter what direction, no matter how many degrees, 90, 180, 270, the numbers 3 and 2 are going to be in my coordinate. It's not going to suddenly change to 4, 7. It's always going to be a 3 and a 2. The order is going to change, the signs are going to change, but the numbers are going to stay a 3 and a 2. To rotate this 90 degrees clockwise, my coordinates are going to change direction or location. So instead of being 3, 2, they're going to be 2, 3. And because I'm going into quadrant 2, my y values in quadrant 4, because I'm going into quadrant 4 down here, because I'm going into quadrant 4, my y values are always negative. So now I know I'm going to be going 2, -3. This is A prime. So I have made a 90-degree rotation around the origin. And if you were to measure this, I don't have a protractor on here, but if you were to measure this, that is a perfect 90-degree angle. I'll make it a little smaller there. There we go. Now that doesn't look like 90 degrees. Let me try this again. There we go, 90 degrees. Now I'm going to rotate it 90 degrees counterclockwise. Oh, I should have made this clockwise. I made green. Okay, so now I'm going to rotate 90 degrees counterclockwise. Because I'm changing quadrants by 90 degrees, my numbers are going to reverse. So it's going to be, again, 2 first and then 3. But because I'm in quadrant 2, my x value is going to be negative. So here I'm going to go -2, +3. So this is my A double prime. So again, I've gone 90 degrees from one coordinate to the next. Now I'm going to go 180 degrees. And it's easiest if you do this in 90-degree chunks, because from one quadrant to the next, the pattern is consistent. If you try to jump from the start to 180, it gets a little confusing. So even if it tells you to do a 180-degree clockwise rotation around the origin, first do a 90, then go to 180. So now I have A prime. I'm going to start from A prime, and I'm going to do another 90-degree rotation. That means my 2 and my 3, I'm going to do this for 180 degrees clockwise. And, I'm going to make this green. There we go. This is going to be 3 and 2. It's going to go back to the same order. But because this is quadrant 3, all coordinates in quadrant 3 are negative, both your x and your y. And so now I'm going to have -3, -2. And this I'm going to call my A double prime. Oh, triple prime. Well, I'll call, yeah, A triple prime. And so what I have done is, you'll notice this is now a straight line. I've made a straight line, which is 180 degrees. And you'll notice that everything is opposite in terms of signs, but everything is the same in terms of order. So order is the same, signs are different for 180 degrees. Now I'm going to do 270 degrees. Counterclockwise. And I'm going to start from 180 because that pattern is going to be the same. So it's going to change the order. And because I'm in quadrant 2, my x is going to be negative. So I can also say -2, +2. This becomes a quadruple prime, or a fourth prime. So a 270 degrees counterclockwise rotation is the same as a 90 degrees this should be clockwise. There we go. A 270 degree clockwise rotation is the same as a 90 degree counterclockwise rotation. And since we already saw that the 180 is the same, I know that my counterclockwise 180 degree counterclockwise rotation is going to be the same as my 180 degree clockwise rotation. So the direction matters because 90 degrees and 270 degrees are going to end you in a different location. You want to make sure that if it's clockwise or counterclockwise, and 90 or 270, that you're going the right way. 180, it's going to be the same either direction. It's going to be straight across, diagonally, no matter where you are starting from. And when you go 90 degrees, every 90 degrees, the X and Y change the order, and the signs follow the quadrants. 1 is positive, positive. 2 is negative, positive. 3 is negative, negative. And 4 is positive, negative. So as long as you know every 90 degrees changes your X and Y order, was 3, 2, now it's 2, 3, then it's 3, 2, then it's 2, 3. And as long as you know the quadrant that you're in and the pattern of the signs, rotations can be long to figure out, but they follow a very specific pattern. Let's look at a two-dimensional one. So I have a line, my two-dimensional, A. Oh, you know what? I want to start it in a different quadrant. I'm going to start it down here. There we go. Usually we go from left to right. So A, B, and I'm going to do a 90-degree rotation. Let's say we do a 90-degree rotation counterclockwise. So 90 degrees counterclockwise. That means I'm going to be going left to this next quadrant because that's 90 degrees. So if I look at my pattern, every 90 degrees, my X and my Y are going to change order. So currently my A is at 1, negative 3. That means my new A is going to be reversed order, 3, 1. And in quadrant 1, I'm going to look for what my signs are. It's positive, positive. So this is going to be A prime. B is currently at 4, negative 3. When I change quadrants by 90 degrees, my order changes. So now it's going to be 3, 4. And in quadrant 1, it's all positive. So 3. Oh, this is 4. Yeah, I wrote negative 3. This should be negative 2. That explains why I was a little confused. There we go. So 2, 4, that's B prime. And now I can connect that. Okay, let's say I want to do a 180 degree rotation clockwise. That means I'm going to go 90 degrees and then 180. So 90 degrees would change it, the order, and they would both be negative. Another 90 degrees would change the order again. And because this is quadrant 2, my X is negative. So I would be at negative 1, positive 3 for A. And B would be 2, 4, change the order, and change the order again. And I've got a negative there because of the quadrant. So negative 4, positive 2, boom. So this is all about direction and how many 90 degrees you have. Because every 90 degrees, your X and Y change order, and your signs follow the pattern of the quadrant.